Hi, I'm Jaskolski, a senior sales engineer with Liberty Systems. I've been with Liberty for about 12 years now. I've had the opportunity to work out in the shop assembling parts, to running the production, to working with application engineering and service, to more recently working in sales. I've also had the opportunity to work with a lot of the laser OEMs and their application engineers to work on flow rate studies and how our systems pair up with laser applications. Today we want to take the time to do an educational video on what are the differences from storage systems to on-demand systems. Typically what we see is about 10,000 cubic feet for storage to 20,000 cubic feet for storage that you're getting quoted from our competitors. Typically how that works out is, to do the math, you can just take, if you have an 8-hour shift, you can take 10,000 cubic feet divided by your 16 hours of downtime. So that means if we have to build a nitrogen generator, we're building 625 cubic feet an hour. Typically you should have a little bit of a buffer in there. And then with 20,000 cubic feet of storage, you just take 20,000 divided by your 16 hours of downtime. That comes out to about 1,250 cubic feet an hour that we have to build every hour while you're gone for the day. It's then gonna go into cylinders. There's a booster that does about 4,500 PSI. And that's gonna store either 10,000 cubic feet or 20,000 cubic feet, depending on what you're quoted. What does that mean when you come in for the day? So once you go to start your first shift, you can pull on a 10,000 cubic foot system, 1,250 cubic feet an hour on average. In a 20,000 cubic feet system, you can pull about 2,500 cubic feet an hour on average. Whereas with an on-demand system, we're gonna size that for your peak flow rate. So we'll look at what you're cutting, and typically you might be around 4,000 cubic feet an hour for one laser. So that's really the differences between, in layman's terms, from an on-demand system to a storage system. So what does that look like in a one-shift operation? Okay, if we're just talking about storage right now. So if we have one laser and one shift cutting 8 hours, if you take 10,000 cubic feet divided by 8 hours of cutting, that means you have 1,250 cubic feet on average. And like I said before, 20,000 cubic feet means you have 2,500 cubic feet an hour on average. So when you come in for the day on the 10,000 cubic foot system, in the first hour, you've consumed 2,000 cubic feet an hour, so you're down to 8,000. 6,000, 4,000, 2,000, and come 12 o'clock, you've ran out of nitrogen. So that means that system is going to have to turn on at some point throughout the day when it was supposed to be a storage system when you come in for the day. So that means that system's always going to be running on a one laser application with 10,000 cubic feet. So you might say, okay, let's go to a bigger system. How does that play out? So if we do that same scenario, we come in for the day, after the first hour, 18,000, 16, 14, and then at about 1 o'clock, a job slid through where we had to cut something thicker. And now we're pulling 3,000 cubic feet an hour instead of 2,000. And we have to do that job for about 2 hours. So then come 3 o'clock, we only have 2,000 cubic feet of storage left, and we're pulling 2,000 again. That means at the end of the day, 4 o'clock, your last hour of the day, we're out again. So that means that system's gonna have to turn on at some point throughout the day. We want to take the time to talk about some of the common myths that we see with storage systems out in the industry. One of the most common things that I see is when you do get that 10,000 cubic foot storage system, when you do go to install it and you realize it's not keeping up, a lot of the times I see the generator companies say, okay, we'll add more cylinders. Well, if it took 16 hours to build that 10,000 cubic feet, it has a very small flow rate. So we can't just add more cylinders because we need more time. Could you do it? Yes. But there is this give-take, and that means that system's gonna be running all the time. And some things that the generator companies won't tell you is that it's about $3,000 every 2,000 hours in just parts to maintain those high-pressure boosters that run at about 4,500 PSI. So adding cylinders without increasing your low-pressure volume isn't the solution. Also to mention, if we look at these cylinders, they're at 4,500 PSI, and typically what I'll see is they're stacked horizontally. So sometimes you might tuck these systems into the corner, or if they're out near a walkway, you have forklifts coming back and forth. If a forklift were to hit those cylinders, that's a dangerous situation. So that's why we like staying in the about 450 PSI range with on-demand. Another scenario is if you had a leak. So let's just say there's a leak in your piping or at the laser. I'm sure you guys have seen that before. In a storage system, it's going to be depleting your volume. Okay, so you don't even notice, it's just being leaking into your ambient air, and then you realize you get a low inlet pressure on the laser. Well, you have to fix that leak, go back, and now you have to wait for those cylinders to build back pressure. With an on-demand system, if you had a leak, you can fix that leak, you get your low inlet pressure at the laser, fix the leak, turn the system back on, and it's running because we always size it based off your peak flow rate. So you may see a lower initial investment with a storage system, smaller footprint. Not all of those systems come with a compressor, but at Liberty, what we like to do in laser applications is do on-demand, a complete package where we control the compressor, the booster, size it for your peak flow rate, and that way we can grow with you. It doesn't matter if you're cutting 1 shift, 2 shifts, 3 shifts, that system's always going to keep up. So if we look at the total cost of ownership, yes, the storage system looked like a smaller footprint, lower initial upfront cost. Not sure what they're showing you on maintenance costs for operating and power, but what's your downtime cost if you did have a leak and that system can't keep up? So when we look at all of those things, the safety behind the high pressure cylinders, I always recommend on demand. It doesn't matter if you're running 1 shift, 2 shifts, 3 shifts like we said. It's better to spend a little bit more and ensure that you always have that nitrogen due to the cost of your downtime. You might be asking yourself, how do I know what's the right system for me? I don't want to have too big of a system, and I definitely don't want too small of a system. So one thing I always recommend is talk to a sales consultant here at Liberty, and we like to take each customer, regardless if you're an existing customer or a new customer, through a discovery stage. We're going to ask key questions like, what are you cutting? How often are you cutting? What edge quality are you expecting for your customers? And you might have found yourself in this situation too. Well, Liberty's telling me one thing, brand X is telling me another, and when I look at the laser manual, it's telling me I need this high purity, this high flow rate. So we can actually narrow that system in for what you're actually cutting. The best thing you can do is rent a flow meter from Liberty, and we can do a data recorder. And we can see over, let's say, a week of cutting, what is your consumption? What are your peak flow rates, your average flow rates? What days are you cutting thicker material or thinner material? With all that data, we can actually size the correct system for you. So I just recommend that you reach out to a Liberty sales consultant and we can walk you through those steps. And we'll be the first one to tell you too that a system doesn't make sense for you today or this is the right system for you.